Hey guys, let's look at 54. This is something that can be a little bit confusing, but it makes sense once you know your cosine, sine, and tangent. And well, we'll just take a look at it. We're used to doing, first off, well, they're called polar coordinates. So in other words, we've already messed around with one way of describing where a point is. The first type we've done is rectangular. In other words, we've done this kind of thing. Indicate the points 1, 4, and -3, -6. Well, at that point, you just go, okay, 1, 4, you go 1 over, and then 1, 2, 3, 4, and there's your point, okay? Or you go -3, -6, okay? You go -3, and then 1, 2, 3, 4, 5, 6, and there you go. In other words, you're sitting from this origin, okay? You go, in other words, we have figured out one way to figure out where a point is from that origin. Somebody can say, well, let's pretend it's miles. You go east 1 mile from where you are, and then you stop and you go north for 4 miles, and then you got it. There you are. And the person says, oh, okay, yeah, I can do that. No problem. The other way of doing that is you can do what's called polar coordinates. In other words, let's say that's the point you want to get to, right? Oops, right here. All right, oops, keep making that thing cut. Okay, let's say you don't want to go over to the right and up. The person, you'll go, okay, how do you get there? The person says, oh, well, you'll go 12 miles out here. And okay, well, let's say that's 12 miles or 12 blocks or whatever it is. No, it better be miles. And let's say you're sailing or flying or something like that. Well, let's pretend you're at this origin. Well, you can't just tell somebody, oh yeah, go 12 miles from your origin. Because the first question the person's going to ask is, okay, yeah, 12 miles, like which way? I mean, I can go anywhere and go up, down, any degree I want to. And the person goes, the degree. Yeah, we need to know that. So the person will say something like, well, you'll need to go 12 miles at, I don't know, let's say 40 degrees. The person goes, okay, sets it up, boom, there you go. Okay, so that's the second way of doing that. That's called polar. And what you'll do is, you would write this, by the way. If you go 12 miles from this origin out and you stop right there and you've gone at a 40-degree angle, you would say it, you would write it that way. And what they'll do in your book is have something like this. Well, you know what, I'll show you a couple of examples, okay. Polar, indicate the vectors given by the notations 4, 57 degrees, and 7, 230 degrees. Okay, they'll have it a little bit different in your book the way it looks, but this is a typical example of what we do. So go ahead and copy this down. You need a piece of graph paper. You know what? No, you don't need graph paper. We do not need graph paper. You do not have to write, you don't have to draw beautiful graphs of angles or anything like that at all. All you need to do is have a blank sheet of paper, be able to somewhat roughly draw a picture, and then go from there, and you're fine. In other words, on your paper, all you'll need is this. You just draw, 2 perpendicular lines, and they'll say change 4 57 degrees to rectangular coordinates. Okay, so in other words, you'll do this. You don't. It doesn't have to be good at all, the drawing. You just go 4, and then you make a little thing here, 57 degrees, and the question is, what is that point? What would we call that in rectangular coordinates? In other words, x's and y's. So you can do this. It's really a neat kind of a process, okay? What you're going to do is, you are going to, you can write these down if you want to, the steps on how to solve this. Number 1, draw a right triangle using a line and angle. So you can pause it if you want and copy that down. Okay, I'm going to go ahead and draw the right triangle. That's a horrible right side, but who cares, all right? Second step is use cosine, sine, and tangent to find the x and find the y. In other words, this is your x, your x-axis, and there's your y, okay? So that's going to be your point, all right? So 4, and this is a 57-degree angle, and, just normal, like we always do it. So let's figure it out, and I'll get this out of the way. Okay, well, we need to find, we don't have to, but let's find x first. And according to the 57-degree angle, that is adjacent, right? We already know the hypotenuse, okay? So what's the one that deals with adjacent and hypotenuse? Cosine, right? Okay, so you're going to write cosine of 57 degrees is equal to x over 4. We know it's 4 because it's the hypotenuse, okay? I'm going to get my calculator out. Okay, so I have 57 degrees and cosine. And there we go. 0.5446. We'll call it 545, I guess. Okay. And 0.5446 or whatever. And you remember, you can put this over 1, cross multiply x times 1 equals 4 times this. So actually on your calculator, you can just go times 4. Oops. All right. Technical difficulties here. There we go. We'll call it 2.18. Okay. So we have now just figured out that x is 2.18. Okay. Now we need to find y. So we're looking at 57 degrees again. That is the opposite this time over the hypotenuse. So opposite over hypotenuse is called sine. Okay, so we need sine of 57 degrees is x over 4. Well, we just go back to our calculator and 57 and then sine, which is 0.838, okay? And we know we can just go ahead and do the same thing. We can just multiply this by 4 times 4, and that equals, we'll call it 3.35, okay? So in other words, now we know that y is 3.35, okay? So we're going to just call it x and y. So we'll say, okay, 2.18 and 3.35. And there you go. That's your x, that's your y. There you go. In other words, telling somebody, oh, you're at a certain point, go east for 2.18 miles and then stop and go north for 3.35 miles and you'll get to a point. You could also say to the person, okay, you're at this certain point, fine. Go 4 miles at exactly 57 degrees and you'll get there. You both get to the same spot. Okay, and that's it. And let's try another one. Oops, I don't need to do those. Okay. Do 7 and 230 degrees to rectangular coordinates. So same old thing. And again, you don't need graph paper. Just draw a horizontal and a vertical line. I just did that backwards, but anyway. Go out and draw an x and y axis and draw just a line, and you don't care if it's 7 whatever is long, just make it, pretend like it is, okay? Whoa, wait a minute though. 230 degrees, we can't just start drawing like this, can we? So this is going to be 90, right? That's 90. This is 180. So this is going to be our line. In fact, I'm just going to go ahead and delete all this real quick. So our line needs to be down here somewhere. We don't care about the perfect, drawing, okay? But we know it's going to be 7. That's the length of this line. 230 degrees, you tell me. This is 90. This is 180. How much more do we have to get to 230 degrees? In other words, this angle right here, how much more is it going to have to be? 50, right? Okay, so this is a 50-degree angle right here. All right, do the same thing we did in the previous slide. Just draw ourselves a right triangle. There's our x, there's our y, and we do exactly the same thing we just did a minute ago. So we're going to have to find, that's a degree there. Oops. Okay, so 50 degrees, we have adjacent over the hypotenuse. So adjacent over hypotenuse, we've memorized, that's cosine. So cosine of 50 degrees equals adjacent over the hypotenuse. What is the cosine of 50 degrees? I have no earthly idea, but I'm just going to pop it in here. So cosine, bam, there it is, okay? All right, we can do the same thing we did just a minute ago, and we will replace this cosine of 50 degrees with what was that, 0.642 something, 7 I believe, 7.8, okay? And again, don't forget, you can just go ahead and cross multiply. In other words, you can just multiply this by this, and that'll give you the answer. Times 7, oops, times, uh-oh, let me clear this all here. So we got 50 degrees And there's my cosine. And then times, oops, no, 7. Times 7 equals, we'll call it 4.5. Okay? So this will be 4.5. Now, one last thing. This will not be normal old 4.5. You look at that graph. Look at the number line. In other words, there's the x-axis, there's the y-axis. If that thing is going to the left, why is that not going to be 4.5 for x? It's going to be negative 4.5, right? Okay, that's what we'll call it. All right. Okay, let's try to find y. Same old thing, we're going to find the sine of 50 degrees is equal to y over 7. And back here to 50 degrees. And we'll find the sine, which is that. All right, and of course we multiply by 7 because that's what we do to find it. And that'll be 5.36. We'll call it 5.36. All right. And again, we'll call this 5.36. And again, you tell me why this will not just be normal old 5.36. What's going to be instead? Okay, yes. It's going to be negative 5.36 because, you know, over here, these are the negatives on the on the x-axis. And going down, these are also the negatives on the y-axis. So in other words, your rectangular coordinate, in other words, your x and y, you're just going to put negative 4.5 and then negative 5.36. There you go. That's it. In other words, you tell a guy, you're sitting right here, I don't know, you're in an airplane or a ship or something like that. And one way to tell him how, help, I'm stranded on some desert island, all right? You can go west 4.5 miles and then turn a 90-degree angle, I'd like to see that in an airplane, and go 5.36 miles south. Okay, and then, or you could just tell the guy, okay, you're right here, go 230 degrees, like that, and then go exactly 7 miles, I guess you can call it southwest or whatever. So, okay. All right, that's how to do those. Okay, try one more. That's a big one. All right, let's try. You want to copy it down? You can. Take a second. Okay, this is what it's going to look like. Again, here we go. 90, 180, 270, and then how much more do we have to go to get to 340? 70 degrees, right? Okay, so in other words, this is going to be, from here to here, will be 70 degrees, right? But we're not really measuring, in other words, we're kind of going like this. Let's pretend like we've drawn our little line there, and it's 42, I don't know, miles long or whatever. This part right here is going to be 70 degrees, right? In other words, 90 plus 90 is 180. 180 plus 90 is 270. 270 plus 70 is 340, but we're not messing with that part. We're just messing with this part right here. So what this is going to be 20 degrees right there. That's 20 degrees, because that's all that's left of this entire 360 degrees. And there's 20 degrees left in just this one quarter. Okay, so we go up with our little drawing. And that's a nasty looking drawing. Let me try that again. In other words, here's where we are. Again, don't worry about making yourself a perfect looking, triangle or whatever. Just go, that's 42 right there, and we got our x, and we got our y. Don't even care if it matches or looks even or whatever. So, okay. Well, now we're messing with 20 degrees. So, we need to find the adjacent over the hypotenuse. So, cosine of 20 degrees equals the adjacent x over 42. Well, let's go find it. Let's clear that out, and we'll go 20 degrees, and we'll find the cosine. And, okay, 0.94 approximately, all right? And go back here, and, 0.94, we'll call it over 1, times 42. We can just, multiply by 42 without even, you don't even have to, don't even clear it out of your calculator on ones like these. You can just leave them. Okay, so 39.5. How about that? Okay, So this one is 39.5. Okay. Same old thing. We need the sine of 20 degrees now. So we'll clear out. And 20. The sine of that is that. And then times 42. 14.36. We'll call it 14.4. 14.4. Don't forget your positives and negatives, depending on what quadrant your point ends up. In other words, this is where you want the guy to be flying to get you. Okay, so our actual rectangular coordinate is 39.5 and negative 14.4. Okay. And again, I hope that makes sense. You're just trying to get a guy, let's say you're on a desert island, you've got a little, whatever, I don't know what those things are called, speak and spell, I don't know. Getting the guy to telling him where you're supposed to be. You can say, fly, negative 20 degrees or 340 degrees at 42 miles, and there I am, or you can just go 39.5 miles east and then 14.4 miles south, and you got me. Just don't land on my head. Okay. All right. The second half of 54 is really pretty simple. It's similar triangles, and we're just solving for one letter, which, I mean, on these kinds, you don't even have to worry about, excuse me, an actual answer as far as a numerical answer. It's just you're going to solve, which means you put everything else on the other side. So they will say solve for D and solve for A. Well, let's just mess with D first. Okay. First off, these are similar triangles. Remember what that means. All the angles are the same. In other words, these vertical angles are the same. They give you these two are the same, which AA means AAA. You learned that already in geometry. Okay, so this is what this looks like with the B on the top and the D on the bottom. You just kind of flip it. In other words, if you just want to forget that, and these are two similar triangles, and they say solve for D. Well, what you can do is go, okay, well, if these are similar triangles, then you can make it your own equation if you want to. You can do it a couple of ways. You can say A over C is equal to B over D, right? And you can see that the top to the bottom equals the top to the bottom. Or you could say, the A to the B equals the C to the D. That's fine. But you want to solve for D, right? You don't want to just have this equation sitting there. You want to get D equals and whatever else is over there. So the easiest way to do this is just to cross multiply. Just go A times D equals, we'll call it B times C, okay? Since you want to solve for D, you just go, okay, well, fine, I'll just divide by A, goes away, and then do the same thing over there. Now I have an equation that says D equals whatever, okay? If you want to do the same thing for A, if you want to solve for A, you still have this same setup here. You can go, again, AD equals BC. Now you're solving for A. Well, fine, then divide by D. D's go away. There's your A. It equals BC over D. Boom, you're done. Okay. All right, let's go ahead and try the practice set and pause it and try A. Okay, this is a perfect chance to show you how you can just do this, without even having any graph paper at all. Just go like this. There you go, there's your X and Y axes. Okay, 28 is the length, so 310 degrees, which means you're gonna have to do a little bit of arithmetic here. So we got 90, we got 180, we got 270. You tell me, how much farther do we have to go from 270 to get to 310? 40, right? Okay. In other words, this part here is 40 this angle here is 40 degrees, okay? We don't care about that angle when it comes to this one, though. We're messing with this triangle that we're drawing, which means we're piddling around with the 50-degree angle right there. That's the one we want because that's how we make a right triangle with one side as the x-axis like we have on all the other ones. So this is our triangle. Here's our X, here's our Y. What is this thing? 28, I don't know, miles or whatever. Okay. So we're gonna have to find out cosine of 50, it looks like. So we got cosine of 50 degrees is equal to X over 28, okay? cosine of 50. I think I did this before. I think I remember, but I don't. 50, and then however your calculator works, there you go. Okay, so that, and then times 28 is going to be right about 18. Okay, we'll just call it 18. Wow, that's really close to 18. Okay, so we'll say that this is 18. There we go. All right, y, same thing. Sine of 50 degrees equals y over 28. Sine of 50, and 5, 0, and a sine. Okay, that. Okay, then again times 28. And 21.4, call it 21.4. So this will be 21.4. And don't forget, this is not just 29.4. In other words, you're writing the x and y rectangular coordinates there. But this will be negative 21.4 because it's going down. There you go. Okay, let's try B. Go ahead and pause it. Try B. Okay, well, the two triangles are similar. Whenever I look at these things, I always have to go, I like to write them, at least draw them, so they're kind of facing the same way, because it always, I don't know, sometimes confuses me. I'm elderly. Give me a break. Okay, so that's what it looks like when you do it kind of like this. All right, so I'm doing that. Okay, so T is over V in this one. Okay, well, we can just do ourselves a little ratio there. So we got R over S is equal to T over V. Or you could put, R over T is equal to S over V, whichever one, as long as you're consistent. Okay, so then solve for R, which means, now this is interesting. Okay, we'll just do the same thing. R times V equals S times T. And we're going to solve for R, so we just divide by V. And there you go. R is there. ST's over V. You got it. Okay. All right. Hope you guys have a good day. Thanks.